All right, we want to talk about antiderivative. We have a function 8x to the fourth plus 5e to the 3x minus 6 cosine of 2x. We want to figure out how to find the antiderivative. Well, there are some derivative rules or antiderivative rules that are given to you, so we can quickly compute that using the reverse power rule, at least for the first guy. We'll call this capital F of x. That's usually what we signify when we mean an antiderivative. We're going to add 1 to the power and divide by the new power. So we're going to get 8x to the fifth over 5. That's just the reverse power rule. This is not a power rule problem, though, or at least this middle term isn't. Then we have an e to the 3x, and the way those get handled are you say plus 5e to the 3x, and you divide by the constant coefficient of x and the exponent of e. Let me repeat that. You're going to divide by the constant coefficient of x and the exponent of e. So instead of 5e to the 3x, you'll have 5e to the 3x over 3. The antiderivative of cosine is sine, so we're going to say minus 6 sine of 2x. But of course, we have to make sure we divide again by the constant coefficient of x inside the sign. This is just a rule that we're going to need to know how to learn. And of course, those integrals are provided to you in a packet or a table of some sort. And then we're going to make sure to say plus c. You can clean this up a little bit. Like we can come over here and say, actually, this hasn't really changed. This would be 8/5 x to the fifth. This will still be plus 5e to the 3x over 3. But you can say negative 6 sine of 2x over 2 is the same thing as minus 3 sine of 2x plus c. And that's simple as it gets. Now, let's look at the next problem. The next problem is kind of a lengthy way of saying that the derivative of the function given to you is basically saying f prime of x equals 2x plus 4 root x plus 1 all over x. They say the slope of the line tangent to the curve f is given by this guy. Well, when they say the slope of the line tangent to the curve, I want you to put a box around that. The slope of the line tangent to the curve, blah, 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 all that says is f prime equals, okay? They're saying f prime equals this thing, okay? If we want to get our hands on f, this is again f prime, I need to find the antiderivative. Now, taking the antiderivative of this might take a little bit of effort because looking like a quotient rule, but there's no quotient rule for antiderivatives. So what we're going to do is we're going to use the fact that this is a single term denominator. I can take that x and divide it into every term in my numerator, therefore giving me 2x over x, 4 square root of x over x, plus 1 over x. Now, to clean this up a little bit, I'm going to say, first off, x divided by x, we all know is just 1. So we're just left with 2. This is x to the 1/2. So we have 4x to the 1/2 divided by x. This is really better known as 4x to the negative 1/2. We can say the power on x is 1 here. 1 subtracted away from 1/2 gives me negative 1/2. And I'm going to leave this 1 over x as a 1 over x. Okay? Now, be careful. A lot of people think we're finished, but we haven't done any antidifferentiation yet. We haven't taken the antiderivative. All we did was simplify. Now let's take an antiderivative. So f of x equals antiderivative of 2 is 2x. Antiderivative of 4x to the negative 1/2, we're going to add 1 to the power and divide by the new power. So this is going to give me 4x to the 1/2 divided by 1/2. We'll clean that up in a second. Plus the antiderivative of 1 over x is natural log of x. This is the only one that doesn't abide by the reverse power rule. So some of you might have thought to say, oh, you know what I'll do? I'll just write 1 over x as x to the negative 1. Yeah, but then you might say, okay, I'm going to add 1 to the power and divide by the new power. But if you do that, you get x to the 0 divided by 0. You can't do that. You can't divide by 0. So this is the only one. This is the only x to some power that doesn't abide by that reverse power rule. And so the antiderivative of 1 over x is ln of x. I'm going to clean this up just a little bit. 2x plus 4x to the 1/2 divided by 1/2 is really 8x to the 1/2, or you can say 8 square roots of x plus ln of x plus c. Now, it does say something to the effect of it passes through the point 1, 5. We're passing through the point 1, 5. So with that in mind, when I plug in 1 for x, I'm supposed to get 5 out for the value of y. So let's erase some stuff here. When I plug 1 in for x here, 2 times 1 plus 8 times square root of 1 plus ln of that value of 1 plus c. I plugged in 1 for x, I'm supposed to get 5. Okay, let's evaluate the stuff on the left-hand side here. 2 times 1 is 2, square root of 1 is 1, times 8 is 8, ln of 1 is 0. So I have 2 plus 8 plus c equals 5. I can subtract the 2 and the 8 over to give me c equals negative 5. Now that I know the value of c, I'm going to go to my updated function, or my integral, my antiderivative, and replace that plus c with the minus 5 that I found it to be. So now this is my new and updated antiderivative function. With that in mind, we can finally complete the problem, which tells us to plug in, I believe the value of x they want us to plug in is 2. So let's plug in 2 now. When I plug in 2, I get final answer of 2 times 2 is 4, 8 times root 2, plus ln of 2, not plus 5, but minus 5. So that would be your final answer. Of course, 4 minus 5, you could say, is negative 1. So that would be your final answer when you plug in 2. Okay, sometimes you're going to be asked to solve some physics problems given some information about the acceleration and the initial velocity about some people. Or, you might be given an initial position, or you might be given an initial velocity, or final velocity, or distance traveled. A lot of different stuff can be thrown at you, and you need to figure out what the other pieces of that puzzle are. So what we start with is we have Brenda, who accelerates at 12 feet per second squared. This tells us this is our acceleration function. Now we can easily get our velocity function from this guy. So let's integrate. If we take the antiderivative of a, we would get v. The antiderivative of a is v. The antiderivative of acceleration is velocity. 12t plus c. So we're given an acceleration. Once we know an acceleration, we can take the antiderivative to get velocity. Antiderivative of 12 is 12t, but don't forget the plus c. Now, we're also told the initial velocity. Let's write down initial velocity. We're told that Brenda's initial velocity is 20 feet per second. So what that means is when I plug t equals 0 in for v, I get 20 out for v. So I'm going to plug 0 in for t here. And I'm supposed to get 20 out for v. I plug in 0 for t, I get 20 out for v. So now I have 12 times 0 is 0, which gives me c is equal to 20. This is hugely important information because now that I have this, I can take my velocity function, which was v equals 12t plus c, and update it. I can now tell me it can tell you the velocity function is now, I don't like that marker. Tell you the velocity function is now, that's much better, 12t plus 20. Well, this is great. Now I've got a velocity function, and the last thing I want to find is how far she's traveled in 2 seconds. So this is velocity. I don't want velocity, I want her position. So I'm going to take the antiderivative one more time. Taking the antiderivative of velocity gives me position. The antiderivative of 12t would be 6t squared plus 20t, and we'll say plus some unknown value d. Now, you could say, well, how can we figure out the value of d? We don't know what this value of d is. For our purposes, we'll just assume Brenda's position is at the origin. We're not told anything about where Brenda starts, or whether she should be starting some point from somewhere else, or there should be some sort of distance that she's already traveled. So for our purposes, we'll just say, make our life easier and say she starts at the origin. Makes our life a little bit easier. So with that in mind, if s of 0 equals 0, it's going to lead us to find out that d is 0. If I told you to plug in 0 for s, while at the same time plugging in 0 for t, you get 0 equals 0 plus 0 plus d, which tells you that d is 0. So this guy can go away. And now I have a position function, s equals 6t squared plus 20t, and I want to find out Brenda's position after 2 seconds. So I'm going to go ahead and plug in 2 for s. I'm going to say s of 2 is equal to 6 times 2 squared plus 20 times 2, which gives us 2 squared is 4 times 6 is 24, plus 20 times 2 is 40, which gives us the final answer of 64. 64 feet traveled in 2 seconds, blazingly fast. Now, the next question talks about John trying to make sure he stops the UT math department from forcing all students to take calculus. I agree with that cause. So what we're going to do is we're going to use a little bit different formula that we're used to. Rather than start with the acceleration and kind of work backwards to find the velocity and the position, we're going to use a formula that we can use that doesn't use time. So ask yourself, does the problem include time? That is to say, do they give you at 3 seconds or after 4 seconds? Or do they say, how far has this person traveled after 6 seconds? Do they say anything about time or number of minutes or hours or seconds that have elapsed? If they don't, use v final squared equals v initial squared plus 2a delta x. This is a formula I call the skid mark formula because it was useful for a problem that you did on a homework assignment maybe a few homeworks ago, where they told you someone was slamming on the brakes and they left skid marks. So with that in mind, you can use this formula. It makes your life super easy, and I don't have to do any sort of antiderivative or initial velocity, anything like that. Well, I mean, there's initial velocity, but I don't have to do any antiderivatives, which makes my life a little bit easier. So let's see what we have to start with. we're told that I think John has acceleration of 8 feet per second squared. We're also told that he accelerates from rest. So accelerates from rest. That tells us that v initial equals 0. The initial velocity is 0. And lastly, we're told how far did John travel. So that's basically how far did he go. That delta x is how far he traveled when v final is 20. So we're going to take all this information we have in blue and plug it into our red formula. So we have a v final, which we know to be 20, equals v initial. We were told he accelerates from rest. With that in mind, we know the v initial is 0. So I have 0 squared plus 2 times a is 8. We're told he accelerates 8 feet per second squared. And delta x is unknown. You can call it question mark, or you can call it delta x. Doesn't really matter. Well, it looks like I have everything I need. 20 squared is 400, equals 0 plus 16 delta x. And if you solve for delta x, you get delta x equals 400 divided by 16 is 25. And notice I didn't have to take a single antiderivative to do that. No integration needed whatsoever. It makes my life super duper easy. So keep in mind, if they don't say anything about after 3 seconds or after 7 seconds or after 9 seconds or anything like that, we can go ahead and use this formula, especially if we're given a final velocity, initial velocity, acceleration, or a delta x, or a distance traveled. If you're given 3 of these variables, you can find the 4th very easily. Notice that I couldn't use this formula for the previous problem that involved Brenda because one of those we weren't given all 4 of those things. We were given probably time. We were given a time, but we weren't given a final velocity or a delta x. So we had, for Brenda's problem, we had initial velocity and acceleration, but we didn't have delta x, we didn't have v final. So it wasn't going to be possible to figure out delta x based on this information. So that's why we didn't use that formula for the previous problem. All right, now we're moving on into rectangular approximation methods. I give you 5 steps for this. It's pretty simple steps. First step, or step 1, let's do it over here, is to find delta x. So step 1, delta x equals b. We can label this as b. Let's label this in red. A, B, and n is the number of subintervals we're using. They told us we're using 4 subintervals, so n is 4. So b minus a over n, which in this case would be 4 minus 2 over 4, which is 1/2. That's step 1 complete. Step 2, we're going to draw a number line. And on that number line, we're going to have a and b as endpoints. So 2 and 4 are our endpoints. We're now going to plug in, we're going to space out tick marks evenly across here. We're using 4 subintervals, so we're going to use 3 tick marks. 1, 2, 3. And we're going to space them out evenly by delta x. So if the first tick mark, or the very far left tick mark, is 2, we're going to go up by 1/2 to make that 2.5. We're going to go up by another half to make that 3. Go up by another half to make that 3.5. And of course, if you go up another half, you'll arrive at 4. Now, step 3 is to circle the endpoints we're looking for. I believe what do I want to say here? When we're told that they use the left endpoint, so because we're being told to use the left endpoints, we're going to circle everything except B. So, when you use the left endpoints, you circle everything except B. When you use the right endpoints, you circle everything except A. Okay? Well, we're told here to use the left endpoint, so we circle everything except B. That's step 3. So I'm going to label that as step 3. Step 3 is a matter of just circling the points. It's a simple step. Circle the points we're going to use. Step 4 is to plug those values, these x values, circled values, into the function. So we're going to have 2 times 2 cubed plus 2 times 2.5 cubed plus 2 times 3 cubed plus 2 times 3.5 cubed. That's step 4. Take all these x values that have been circled, plug them into the function, and add them all up. Step 5 says we wrap this guy in brackets and multiply the very end by delta x. Our delta x was 1/2, so don't forget, bring him down and multiply by 1/2. Whatever this giant monstrosity of a number comes out to be is your answer. Now, more often than not, in a test situation, these numbers aren't going to be so bad that you can't do this with a calculator. But obviously for this one, you might want to grab a calculator, multiply these numbers out, and then add them all up, multiply by 1/2. You might even see these answers left as is for an answer choice on the test, because they don't want you going ahead and squaring all this out, or rather cubing all this out, adding it all up and multiplying by 1/2. So you could leave it like this, or if you have a calculator, go ahead and crank that number out. But otherwise, come test time, the number's gonna be very, very easy to handle. Cool? All right, next question. The next question, we have a graph. Let me see if I can remember these numbers here. Okay, when you're asked to find bounds using rectangular approximation method, all it's telling you to do is find the left approximation method and the right approximation method and use a sandwich, make that into a sandwich. So we're going to do the left approximation method. The left approximation method says, here's my number line. Number line goes from 0 to 5. When I'm using the left approximation method, I'm going to circle these endpoints, 0, 1, 2, 3, and 4. So I'm going to go ahead and add these all up. The value at 0 is 2. The value at 1 is 3. The value at 2 is 6. The value at 3 is 7. And the value at 4 is 12. Step 4, we're kind of skipping steps 1, 2, and 3. Steps 1, we actually didn't find delta x. We're kind of skipping a few steps here, but we'll manage. We've gone ahead and circled the corresponding x values. That's our step 3. Step 4 is to find the corresponding y values and add them all up. So 2, 3, 6, 7, and 12. Let's go ahead and add these all up. 2 and 3 and 6 and 7, that makes 30. All this makes 30. And then remember, step 5 is to multiply by your delta x. Well, what was delta x in this situation? The spacing between each tick mark is your delta x. So the spacing between 0 and 1 is 1. The spacing between 1 and 2 is 1. The spacing between 2 and 3 is 1. We can see that our delta x equals 1. So I'm going to multiply this entire summation by 1. That doesn't change much of anything, but that means your left-hand approximation is 30. Now, we have to do the right-hand approximation because we're trying to figure out bounds on the total area. So let's go ahead and get the right-hand approximation. The nice thing about finding the right-hand approximation after finding the left-hand approximation is that it's going to use mostly all the same values. We're going to use 3, 6, 7, and 12, but we're going to drop the 2. So this time, if you want to, you can... I'm going to put a box around the tick marks I'm going to use here. So I'm going to put a box around the 1, the 2, the 3, the 4, and the 5. I'm going to use those 5 values as opposed to the circled 0, 1 through 4. So I'm going to use 1, 2, 3, 4, 5, and those values are 3, 6, 7, 12, and the corresponding value for 5 is all the way up there at 15. Add that all up, you'll get 43. And again, we're going to multiply by our delta x. Delta x here was 1, so I'm going to say times 1. That gives me a final answer of 43 for the right method. So what you can say is, I'm going to erase this graph now. The left-hand method gave me 30. The right-hand method gave me 43. So the area is somewhere between 30 and 43. Something else I want to point out about this is that the function that I just erased was an increasing function. So that for an increasing function, let's say if f is increasing, then the left approximation method is an underestimate. That is to say, the actual area is probably something bigger than 30. And in fact, our inequality reflects that. The actual area might be somewhere around 35 or 36 or 37, somewhere above 30. So the left-hand approximation is an underestimate. And if the left-hand approximation is an underestimate, R is an overestimate. Like I said, 43 is a bit kind of large. We probably expect the area to be somewhere between 30 and 43, maybe around 35, 36, 37. So with that in mind, the right-hand approximation method that we used gave us an overestimate. Now, that's if f is increasing. But something that's important to keep in mind is that if f were decreasing, these guys would be switched. So if this was decreasing, then this would be an overestimate, and this would be an underestimate. So rewind the video if you have to copy that all down, but basically the tables are turned when you say f is decreasing. L is suddenly an overestimate if it's decreasing, and R is an underestimate. All right, this problem is super tricky. We're going to try and convert this integral to a Riemann sum. Now there are a couple formulas you need to know. You need to know limit as n approaches infinity of summation from I equals 1 to n of f of xi times delta x. And you also need to find out what xi and delta x are. So let me go provide those formulas over here. Delta x equals b minus a over n, and xi equals a plus I delta x. Whew, there's a lot up there, but make sure you know all of those formulas. Now, what I'm going to do is, in order to convert this, I'm going to find b minus a over n. So here's my integral. This is b, this is a. So my delta x is really 3 minus 1 over n, or just 2 over n. The corresponding value of xi would be, again, my value of a is 1 plus I times 2 over n, the delta x that I just found. So xi equals 1 plus 2I over n, while delta x equals 2 over n. Okay, now I have all this information. I'm going to start plugging it into converting this integral to a summation. So watch me go. I'm going to have limit as n approaches infinity of the summation from I equals 1 to n of the function is x squared minus, I'm going to need a little more room than that. The function is x squared minus 2x. But instead of saying x squared minus 2x, I'm going to replace each instance of x by the xi I found here. So instead of saying x squared minus 2x, I'm going to say, let's do this in blue, 1 plus 2I over n squared minus 2 times, and again, instead of saying x, I'm going to say 1 plus 2I over n. Now that just takes care of the f of x sub I. So all I've done is take the function x squared minus 2x and replace every instance of x by 1 plus 2I over n. The last thing I need to do is multiply by delta x. So delta x comes down here, fx of I comes there, and so delta x was 2 over n. Now this is all you would need to do in order to set up the Riemann sum. You could, if you want to, expand everything out, combine like terms and whatnot, but this is probably sufficient in order to get an answer. But if you want to expand everything out, and that's going to be actually important for the next part that we do, is to expand everything out, we're going to have limit as n approaches infinity of the summation from I equals 1 to n of, I'm going to expand this, here we go, 1 plus 4I over n plus 4I squared over n squared minus 2, make sure you distribute the negative 2 to the inside here, minus 2 minus 4I over n, and this is all times 2 over n. Giant mess. Now, we see a plus 4I over n, that cancels, a minus 4I over n, that cancels, so we're left with limit as n approaches infinity of summation I equals 1 to n of 1, or actually, you know what, I'm not going to say 1, I'm going to say 1 minus 2 is negative 1 plus 4I squared over n squared. Those guys canceled, and I'm just left with multiplying by 2 over n. You could even just say limit as n approaches infinity, summation, I'm not even going to write the index this time. The 2 over n gets distributed to the inside, leaving me with negative 2 over n plus 8I squared over n cubed. And that's the Riemann sum, or at least again, this is all still part of part A, where convert the integral to a Riemann sum. You could leave it like this, or you could go all the way out to expanding and getting this down. This would be fine, this would be fine, either answer is fine, just keep in mind that they might use this as an answer choice rather than this. Now, the next part of the question tells us to evaluate this limit as n goes to infinity and get an answer to compute the integral. How do we do that? Well, before we go on with this, I'm going to need a couple formulas. I'm going to use the fact that summation of 1 from I equals 1 to n is equal to n. If you're wondering why that is, or what the hell that even means, it means you're adding the number 1 to itself n times. So basically doing 1 plus 1 plus 1 plus 1 plus 1, and I'm adding the number 1 to itself n times. What happens when you add the number 1 to itself n times? That would give you n times 1, right? Think about what that would mean if you said, I want you to add the number 17 to itself 20 times. So that would be 20 plus 20 plus 20, or 17 plus 17 plus 17, 20 times. That would be 17 times 20. In much the same way, I'm adding the number 1 to itself n times. That would just give me n. Another formula that is given to you, they tell you that 1 squared plus 2 squared plus 3 squared plus 4 squared and so on, is equal to this formula 1/6 times n plus 1 times 2n plus 1. So what they're telling you here is when they say 1 squared plus 2 squared plus 3 squared and so on and so forth is equal to, that's equal to summation I squared. So keep in mind, this is 1 squared plus 2 squared plus 3 squared plus up till n squared. Okay, so they give you this formula because they know you're going to use it for this summation. So let's come back down here. I'm going to do a couple things. I'm going to split the summation into two different sums. Negative 2 over n plus summation 8i squared over n cubed. And by the way, something that should be apparent, though I'm not doing it, is there should be I equals 0, not I equals 0, but I equals 1 to n, I equals 1 to n. I'm not going to be doing that for every time I write a summation, but understand that there will be I equals 1 to n every time. Now, I've gone ahead and split the summation. I had a sum of two different terms. I'm going to say, you know what, split those guys apart. It's going to make it a little bit easier for me to finish this up. What is the summation of negative 2 over n? Well, we know what we'd rather do is we're going to factor out negative 2 over n out of this summation. In fact, you can factor out anything that is not an I. So this entire thing does not contain an I, and so I'm going to factor it out. When I factor negative 2 over n out of negative 2 over n, I'm just left with 1. Plus, I'm also going to factor out 8 over n cubed out of this next summation. Notice I've done that for a good reason. Notice that now I've factored out that negative 2 over n, I'm just left with the summation of 1, which I know is right there. Also, I factored out 8 over n cubed, leaving me with just summation of I squared, which I know is right here. So I'm going to replace these summations with their values. Negative 2 over n times n plus 8 over n cubed times 1/6 n times n plus 1 times 2n plus 1, close parentheses. And now I've gotten rid of the summations, right? The summations are now gone. The summation of 1 became n. The summation of I squared became 1/6 n times n plus 1 times 2n plus 1. This is super great. Now, the last thing I need to do is take the limit as n approaches infinity. Before I take a limit as n goes to infinity, I'm going to go ahead and cancel this n. I'm also going to cancel this n with one of the n's down here. I'm also going to cancel an 8 and a 6 to make a 4/3. So I did a lot of canceling, but all told, when I clean this all up, I get limit as n approaches infinity of negative 2 plus 4 times n plus 1 times 2n plus 1 all over 3. Okay, this limit actually seems pretty straightforward. I can compute this limit pretty quickly. Up 3, not 3, but 3n squared. There we go. I can compute this limit pretty quickly. I have n times 2n times 4. That would give me, let's do this. Here's what I'm going to say. I'm going to multiply all of this out. So this would be, this would be 2n squared plus 3n plus 1, but I'm multiplying by a factor of 4. So it would be 8n squared plus 12n plus 4. When I take the limit as n goes to infinity of this, I get, well, the degree of the numerator is 2, the degree of the denominator is 2. So I can take the ratio of the leading coefficients, giving me 8/3. So 8/3 would be be the limit of this rational function, but don't forget there's a minus 2 still hanging out over here. So I get, as my final answer, negative 2 plus 8/3. 8/3 minus 2 gives me a final answer of 2/3. And that's all it took, all said and done. A lot of work, and there was stuff even that I've even erased here. Now, let me show you the quick and dirty way to do this. They want us to evaluate the integral from 1 to 3 of x squared minus 2x. Seems pretty straightforward to me. Can I integrate x squared minus 2x? Yes, I can. That would be x cubed over 3 minus x squared. And now that I've gone ahead and taken the antiderivative, now that I've integrated, I'm going to plug in my upper bound, plug in my lower bound, and find the difference. So here I go. 3 cubed would give me 27 over 3 minus 9, minus what I get when I plug in 1. This gives me, let's clean this up down here, 27 over 3 is 9, 9 minus 9 is 0, minus 1/3 minus 1 is negative 2/3. So my final answer is negative 2/3, which is 2/3. But hey, that's exactly the answer I got from here doing the Riemann sum. So notice the Riemann sum took a lot of work, but the antiderivative, or taking the integral from 1 to 3, gave me the same exact answer. So obviously, given a choice, you'd much rather do the antiderivative or to use the integral method in order to figure out the answer rather than work through all that Riemann sum stuff. Now, of course, if the answer requires you to find the Riemann sum and show the work for it, then by all means do the Riemann sum. But if it just wants you to get a number, if the multiple choices are just numbers, do the integral and get your number really quickly. Okay, now we want to find the Riemann sum represented by the area underneath the curve cosine 2x on the interval from 0 to pi over 6. Simple enough. That just means we need to go find delta x. That would be pi over 6 minus 0 all over n. xi would then be 0 plus I times delta x, which would be pi I over 6n. We're going to clean this up a little bit over here. Pi over 6 minus 0 all over n is the same thing as pi over 6n. So delta x is pi over 6n. 0 plus I times delta x would be pi I over 6n. Now, all I need to do now is write limit as n approaches infinity, summation from I equals 1 to n of, what's my function? Function is cosine 2x. So I'm going to say cosine of 2, I won't say 2x because again, you're not supposed to say cosine of 2x, you're supposed to say what xi is. So xi is this pi I over n. So instead of cosine of 2x, I'm going to say cosine of 2 times pi I over 6n. And don't forget, the Riemann sum needs you to multiply by delta x on the very end. So times pi over 6n. I'm going to clean this up. There's one small cleanup to do, really, honestly. There's a 2 over 6. Well, 2 over 6 is better known as 1/3. So I'm going to replace the 2 pi I over 6n by pi I over 3n. This confuses a lot of people because they're wondering where they're looking for an answer choice that has a 6 in the denominator, but they'd only see a 3. Remember, this is because this is cosine of 2x. So that factor of 2 multiplies by the pi over 6n and gives us just pi I over 3n. Cool? Simple as that. Now, next problem is a little bit trickier. So we're given a Riemann sum. We're given the limit as n approaches infinity of the summation from I equals 1 to n. I believe 3 plus 4i over n squared times 4 over n. This messes up a lot of people. So, first things first is, rather than try and figure out which integral this represents, it's easier to go ahead and eliminate answer choices it can't be. So, a brief aside. It's easy to go from an integral to a Riemann sum. It is difficult to go from a Riemann sum to an integral. And this is because there's lots of different ways to represent the same Riemann sum. So here's what we're going to do. We're going to look at answer choice 1, which says 3 plus 4x squared on the integral of 0 to 4. Here, they've let the answer, or they've let the value of a equal 0. So they said a equals 0. Furthermore, we see that b is 4. So from there we can say delta x equals 4 over n. And that doesn't seem too surprising. If delta x equals 4 over n, I see delta x right there. However, xi would then be, our value of a is 0. Our value of delta x would just be 4 over n, so we have I times delta x, or 4i over n. So let's go change. Great. Anyway, we have xi equals 0 plus 4i over n. Let's go changing the inside of this integral, 4i over n. Well, if x equals 4i over n, this function is really 3 plus, again, x is 4i over n. So this would be 3 plus 4i over n is here, 4i over n is here, so it would be 3 plus x squared. But I have 3 plus 4x here. So this cannot be a correct answer. We found xi to be 4i over n. So when we look back at our summation, we have 3 plus 4i over n. This would be x. But here we have 3 plus x. Here they have 3 plus 4x. So that means answer choice 1 cannot be correct. We're going to rewind this and do it all over again, but now for answer choice 2. Answer choice 2 says 4 times 3 plus x squared. And the integral goes there from 0 to 1. Okay, let's decipher and kind of dissect what their choices for A and B were. Here they let A is 0. Here they let B equal 1. With that in mind, delta x is 1 over n, and therefore xi would be 1 over, or I over n. Okay, let's look back at the original summation. Here we have 4 over n, but our delta x is is 1 over n. That's okay. Here's what I'm going to do with that 4. I'm going to erase the 4, pull it out in front, and put a 1 up here. So now I have delta x equals 1 over n. That checks out. My xi is 1 over n. So what do I have here? This would be 4 times 3 plus. Since I over n is equal to xi, this becomes 4x squared. But that doesn't match answer choice 2. Answer choice 2 says we have 4 times 3 plus x squared, but according to our summation and our choice for xi, we would get 4 times 3 plus 4x squared. And again, where am I getting that 4x? This is 4i over n, but my xi was I over n, so 4i over n would be 4x. Answer choice 2, on the other hand, says 3 plus x. So we know answer choice 2 cannot be right. Okay. Maybe it's answer choice 3. I'm going to erase the 4 and bring it back to the right-hand side over here. Answer choice 3 says integral from 3 to 7 of 4x squared dx. Okay, once again, let's dissect this answer choice. Their choice for A is 3, choice for B is 7, so delta x equals 4 over n. That means xi would be 3 plus 4i over n. Okay. Let's kind of figure out what this should say then. This would be, if we convert this, if xi is 3 plus 4i over n, well, guess what I have? This entire thing is x. Let me rewrite this. We just, according to this integral over here, found that delta x equals 4 over n. That means xi is 3 plus 4i over n. Well, look what I have inside that parentheses. I have 3 plus 4i over n. So this entire thing is just x squared. And it's the integral of x squared from 3 to 7. This, however, does not match answer choice 3. Answer choice 3 has a 4 here. So answer choice 3 is wrong. And in fact, this is exactly equal to answer choice 5. So answer choice 5 is correct. You can go ahead and mark that off. This is exactly answer choice 5. So I've converted the 3 plus 4i over n to an x. I converted the 4 over n to a dx. So that's fair. Now, what about answer choice 4? Let's go ahead and look at that. Because I know I said it's answer choice 5, but it turns out that answer choice 4 is also correct. This is a testament to how you can choose to rewrite your Riemann sum in a multitude of ways. So, answer choice 4 says integral from 0 to 1 of 4 times 3 plus 4x. I actually think we solved this a second ago for answer when we were trying to figure out answer choice 2. So let's do this again, but then we'll do it one more time. Why not? So, what we've done here is we've taken the 4, made it a 1, and pulled the 4 out in front. This is what explains the width of the interval being from 0 to 1. How wide is that interval? It's a width of 1, and so we get a 1 over n for our delta x. Delta x equals 1 over n. That makes xi equal to, a is 0, so 0 plus I over n. Now, we're going to convert this sum here, summation, well, we're not going to say sum, we're going to say 4 times 3 plus, since I over n is equal to x, we're going to replace I over n by x, giving us 4x squared dx, and we're integrating this from 0 to 1. Hey, do we have a match here? We do. We've got a match. So this is answer choice 4, and when we dissected their choice for A and B and plugged all this in and found out what delta x and xi was, we did all this work, we got the exact same thing that they did. There wasn't a discrepancy in the coefficient of 4, there wasn't a discrepancy in the 3, there wasn't a discrepancy in the 4 here, so everything checked out, everything matched what the answer choice 4 did, as I did in 4, so that means this must be a correct answer. So answer choice 4 is also correct, along with answer choice 5. Okay, so the thing about a definite integral is it gives you the net area under the curve. So keep that in mind. When I ask for a definite integral gives you the net area under the curve. When asked to find the area, or the integral 2x minus square root of 16 minus x squared here, I'm going to split this up into 2 different integrals. One of these integrals goes from 0 to 4 of just 2x, And the other integral goes from 0 to 4 of square to 16 minus x squared. Now, these graphs form two shapes. This graph is going to form a triangle. And this graph is going to form a semicircle. I've written that very strangely. There we go. Let's clean it up. So, triangle and semicircle. The triangle formed by the graph of y equals 2x looks like this. Here's 0, here's 4. This coordinate, because this is the graph y equals 2x, would be 4, 8. When I plug 4 in for x, I get 8 out for y. So I can figure out pretty easily what the area of this triangle is. The width is 4, the height is 8. Area of a triangle is equal to 1/2 base times height. The base is 4, the height is 8. So the area of this triangle is 1/2 times 4 times 8, which is 16. Now, this guy is the area, this is a semicircle. So a semicircle of radius 4, let's draw this a bit bigger. Semicircle of radius 4, and I only want the area from 0 to 4. So I only want this chunk of area. Notice this would be 1/4 the area of a circle. Now the area of a circle is pi r squared. So what I'm going to do is I'm going to plug 4, my radius of my semicircle, in for r. This is going to give me pi times 16, or 16 pi. But I don't want the full circle. That would be the whole area of the whole circle. I only want 1/4 of it. So I'm going to divide this by 4 to give me an area of 4 pi. Be very careful because this is the area contribution from the semicircle. This is the area contribution from the triangle. So the net area would be 16 minus, there's a minus separating the 2x and the square root of 16 minus x squared, minus 4 pi. This will be our final answer. Now the next question has a graph that something looks like this. Actually, it doesn't have a graph, but it tells us some graph. So I should say 0 to 5. They tell us is 4. Interval from 0 to 3 is 7. And they tell us the interval from 5 to 7 is 2. So we've got, well, I think there's a graph, isn't there? There's a graph. I'm done. So they tell us the interval from 0 to 3 is 7. We're going to go ahead and say this is, this is 0, this is 3, this is 5, this is 7. From 0 to 3, this much is 7. Now we know the net from 0 to 5 is 4. That is to say, from 0 to 3 is 7, and 3 to 5, we don't know, but we know this total area from 0 to 5 should be 4. So it must mean the area from 3 to 5 is 3. But it's 3 sitting underneath the x-axis, and here's why. We know that the integral from 0 to 5 is supposed to be 4. So that gives us the positive 7 from the top and a negative 3 from the below, from the underneath the x-axis. So this all checks out. From 0 to 3 is 7, from 3 to 5 is negative 3, so from 0 to 5 we get 7 minus 3, which is the 4 we're looking for. Alright, and the last piece says that the interval from 5 to 7 is 2. And with that in mind, we can start to answer all these questions. So what would the integral from of 3 times f of x be from 0 to 7? Well, this is pretty simple. It's a matter of figuring out how much area is on top. That would be 7, and 2 is 9. Subtract the 3 to give us 6. So that would give us a net area of 6, but we're going to multiply that by 3 for a final answer of 18. Now, the next question asks us to find the integral not from 3 to 5, but from 5 to 3 of f of x dx. A little tricky because now the big bound, or the upper bound, is the smaller number, which is kind of weird and confusing. So what we can do instead is say negative integral from 3 to 5 of f of x. And that's a lot more appropriate. That's what we're accustomed to. We're accustomed to the lower number being on the bottom and the upper number, or the upper bound, being a bigger number. What is the integral from 3 to 5? Well, the integral from 3 to 5, we know, is not 3, but negative 3. So this tells us, let's get this out of here, we have negative 3. So negative 3 gives us an answer of 3. Yeah, okay, next question. Last one asks us for integral from 0 to 5 of absolute value of f of x. So here's all that changes. Any part of the graph that's negative must become positive. So instead of this hump being down here, when I take its absolute value, it becomes positive. So now I merely ask myself, what is this area plus this area? I'm no longer subtracting that area because now it's on top. 7 plus 3 is 10, and that's my final answer for that problem. All right, now we're dealing with the fundamental theorem of calculus. Here's what we have. We have some integral from 3 to x of t cosine of t dt. Now, if this is some function, we'll say f of x, and I want you to find f prime of x, all you need to do is the following step. You're going to take, let's get a red marker for this, you're going to take the upper bound of x, plug it in for t here and t here, and then you're going to take the derivative of that upper bound and plug it in for here. So we'll say derivative. Okay? Let's do that right now. So I'm going to plug in x for every instance of t that I see. So I have x cosine of x, and then I'm going to take the derivative of that upper bound, which is 1, and plug it in for dt. That would just be times 1. Now we're halfway there. We are then going to subtract what we get when we do the same thing, but now for the lower bound. Coming out of focus there. Come back into focus. Okay. 3, when I plug it in for t here, and then the derivative here, you might realize that the derivative of 3 is going to be 0, so just poof and goes away. But let's just plug it in anyway. 3 cosine of 3, and then the derivative of 3 is 0. So times 0 causes that thing to just vanish and go away. Don't even bother to write it. So we get a final answer of x cosine of x. Now, what about the next integral? What about the integral of 2x? Let's say this is some function f of x equals the integral from 2x to x squared of ln of t squared minus 1 dt. Once again, we're going to do the same process. We're going to take, when we want to find f prime, we're going to take x squared, plug it in for t, and plug its derivative in for dt. Let's go ahead and do that. This would give me ln of x to the 4th minus 1 times the derivative of x squared, that's 2x, minus what I get when I plug in 2x for t and the derivative of 2x in for dt. So that would be ln of 4x squared minus 1 all times 2. That's all there is to it. I actually don't know why I used the entire top half. I could have gone down here, but that's all there is to this. Take x squared, plug it in for every instance of t, and its derivative in for dt. Take 2x, plug it in here for t, and dt is derivative in for dt, and then find the difference. That's all there is to it. So, what's going on here is that the order of the derivative in the integral has been switched. So, if I take the derivative of the integral from a to x of g of t dt, I will get what I did before. I'm just going to take the x, plug it in for t, plug the derivative in for dt, and I would get g of x times 1, and of course do the same thing here minus a goes in for t and the derivative of a in for there. The derivative of a, though, remember a is a constant here, is 0, so it'd be g of a times 0, which just actually means this guy goes away, and we're left with just g of x. Now, what about the right-hand side? What about this guy? Here we're going to use the fundamental theorem of calculus to evaluate it. The antiderivative, or the integral of g prime of x would be g of x, but or not g of x, but g of t. The antiderivative of g prime of t would be g of t, and we're evaluating from the bounds a to x. So when I plug in x, I get g of x, minus what I get when I plug in a. So minus g of a. Is this the same thing as this? That is to say, this was my left-hand side, this was the right-hand side. The left-hand side of the equation, when I took the derivative of the integral, just gave me g of x. When I took the integral of the derivative and plugged in my bounds, I got g of x minus g of a. Are those the same? No, they're not the same, so the answer to this question is false. All right, that finishes it up.